to Math Maxtra. This is Saritha. Today we will discuss a topic of relation between the quadrilaterals as well as and the figures, different types of figures formed by joining the midpoints of the sides of different quadrilaterals. Okay, so our first topic is relation between the quadrilaterals. We have discussed all the properties of each quadrilateral, different types of quadrilaterals. So among those, so what is the relation? See, we have seen that all the squares are rhombus and all the squares are rectangle as well. See, both rhombus and rectangle is nothing but a square. Yes, so that is why all the squares are rhombus, all the squares are rectangle, and we know that all the rhombus are parallelogram, isn't it? And all the rectangles are also parallelogram, isn't it? Next, all the parallelograms are trapeziums. All the isosceles trapeziums also comes under trapezium only. All the kites are quadrilaterals as well as all the trapeziums are quadrilaterals. So, this is the relation between the quadrilaterals. Okay. Now, we will discuss the figures. What are the different types of figures formed by joining the midpoints of different quadrilaterals? See, if you take any quadrilateral, okay, so let us consider this is one quadrilateral. Okay, this is any type of quadrilateral. We don't know what it is exactly. Okay, this is a ABCD quadrilateral. Okay, so now what we are doing? We are joining the midpoints of the sides. First, locate the midpoints of all the sides. So these are the midpoints of all the sides. Okay. So let us consider this is a PQRS points, midpoints. Now you see, now we have to decide which, if you join all the midpoints of the sides of a quadrilateral. So I am joining all the midpoints of the sides of a quadrilateral. We want to know what type of figure this PQRS is. Okay, how can we check? Now I am drawing a diagonal which is AC diagonal. Okay, this is a diagonal of a quadrilateral ABCD. Okay, now if you consider a triangle ADC triangle, see that in triangle ADC. So this is the triangle ADC. So what we are doing? We are joining the midpoints of two sides. Yes, in a triangle, if you join the midpoints of the two sides and this line segment will be automatically parallel to the third side and exactly half of it. We have a property that in a triangle, if you join the two midpoints of the sides of a triangle and that line segment will always be parallel to the third side and exactly half of it. So, okay, so in that way, we are joining the midpoints of these two sides and this is automatically parallel to AC, isn't it? So these two are parallel as well as this line segment is exactly half of it. Yes, which is nothing but AC by 2. Yes, this length is AC by 2. Similarly, if you consider a triangle ABC triangle, what happens? Again, we are joining the midpoints of these two sides in this ABC triangle and this line segment, PQ line segment automatically parallel to third side and exactly half of it, isn't it? So this is parallel to AC and exactly half of the third side, which is nothing but AC by 2. Okay. Now, as this is parallel to this and this is parallel to this, these two automatically parallel. A pair of opposite sides are parallel, isn't it? And similarly, if you consider BD line segment, then also the same thing happens. As BD is the, if you take a triangle ABD triangle, If you join BD diagonal in a quadrilateral and you will get a triangle ABD triangle. In the ABD triangle, we are joining the midpoints of these two sides and this line segment is automatically parallel to BD and exactly half of it, isn't it? So this is the length of BD by 2. Similarly, this will also be BD by 2, isn't it? So now we have seen that these two are parallel and equal. These two are parallel and equal, isn't it? These two are parallel and equal. So two pairs of opposite sides are parallel as well as they are equal. That is why we can call this PQRS quadrilateral as a parallelogram. We don't know what are the angles at the vertices of PQRS. That is why we have known only two properties, that the two pairs of opposite sides are parallel as well as equal. That is why we can say that quadrilateral is a parallelogram. So, if you join the midpoints of any quadrilateral, random quadrilateral we are considering, and we are joining the midpoints of those sides of that quadrilateral. Okay, so what we have got? We have got a parallelogram. So if you join the midpoints of a sides of a quadrilateral, we will get always a parallelogram. Okay. And in the second case, let us consider a trapezium. See, this is a trapezium. Now, we have to locate the midpoints of the sides of a trapezium. These are the midpoints of a sides of a trapezium. Now I am joining these midpoints. These points are, let us consider P, Q, or S are midpoints of a trapezium, and we have joined all the midpoints of a trapezium. We got one quadrilateral. We have to decide which type of quadrilateral the PQRS is. Okay. Now I am joining a diagonal AC of a trapezium. See. So what I did? I have joined the diagonal AC. And see, if you consider ADC triangle. So similar to the previous case, here also we are joining the midpoints of the two sides of a triangle and which is always parallel to the third side and exactly half of it, isn't it? So this is AC by 2 and this is also AC by 2 if you consider a triangle ABC, and if you join the BD diagonal and that this will automatically BD by 2, isn't it? ABD triangle, and if you consider BDC triangle and you will get this is BD by 2, similar to the previous case. Okay. So what we have got here also, we have got that two pairs of opposite sides are parallel as well as equal. So by that we can say that this PQRS quadrilateral is a parallelogram, isn't it? So if you join the midpoints of a sides of a trapezium, we will always get a parallelogram. Third case is, I am considering an isosceles trapezium this time. In the isosceles trapezium, the non-parallel sides are equal, isn't it? See, this is a isosceles trapezium ABCD and these non-parallel sides are equal, which is nothing but AD is equal to BC. So now I am locating the midpoints of the isosceles trapezium. I am joining those midpoints. We have to decide which type of quadrilateral it is. So these PQRS are the midpoints of a quadrilateral isosceles trapezium. Okay. So if you consider ADC, so if you join the diagonal and if you join BD diagonal also, And we have a property in the isosceles trapezium that the diagonals always not only intersect in the proportional, they are always equal in length, which is nothing but AC is equal to BD, isn't it? So we know this AC is always equal to BD in case of isosceles trapezium. That is why, see, if you consider ADC triangle and we are joining the two midpoints of the two sides of a triangle, this will automatically parallel to the diagonal AC as well as exactly half of it. Yes, AC by 2. Similarly, this is also of length AC by 2, and just now we have seen that this is BD by 2 and this is also BD by 2. But we know very well that AC is always equal to BD by 2. So we can replace this BD by AC, isn't it? AC by 2, and this is also equal to AC by 2. Now we have got a different quadrilateral other than parallelogram. See, all the sides are equal. AC by 2, AC by 2, AC by 2, ACD by 2. Isn't it? And we don't know the angles at the PQRS vertices. That is why we have only one property, that all the sides are equal as well as and opposite pair of sides are parallel. Yes, these two sides are parallel, these two sides are parallel, and adjacent sides are equal. So what are those properties applicable for which type of quadrilateral? Which is always a rhombus, isn't it? Adjacent sides are equal and the opposite pair of sides are parallel. So we can confirm that if you join the midpoints of a sides of a isosceles trapezium, you will always get a rhombus. I am considering a parallelogram. This is a parallelogram. This is a parallelogram ABCD. Now I am joining the midpoints of all the sides. So we have to identify this PQRS is which type of quadrilateral. Okay. See, as this is a parallelogram and this I am joining a diagonal AC. So if you consider ADC triangle, see, these two are midpoints of the sides of a triangle and this line segment will automatically parallel to the third side and exactly half of it, isn't it? So this is AC by 2 and this is also AC by 2. These two are parallel. And similarly, if you consider BD diagonal and there BDC triangle, so we can see that this is BD by 2 and this is also BD by 2. So what happens? Two pairs of opposite sides are parallel and equal. So we can confirm that it is a parallelogram. This PQRS is a parallelogram. So if you join the midpoints of a sides of a parallelogram, again you will get a parallelogram only. Next case, I am considering a rectangle. This is a rectangle. ABCD rectangle. I am joining the midpoints of this rectangle. So this PQRS is a quadrilateral. We have to identify which type of quadrilateral this PQRS is. So I am considering a diagonal AC and I am also consider a diagonal BD. We know that in the rectangle, the diagonals are always equal in length, isn't it? They bisect each other and they are equal in length, isn't it? So if you consider ADC triangle, this RS length is automatically AC by 2 and this is also AC by 2 And if you consider this BDC triangle, this length is BD by 2 and this is also BD by 2. But we know that in the rectangle, diagonals are always equal. AC is equal to BD. So this will automatically equal to AC by 2 and this is also equal to AC by 2. Now you see the opposite pairs of sides are parallel as well as adjacent sides are equal. So these are the properties are applicable to rhombus, isn't it? So that is why if you join the midpoints of the sides of a rectangle, you will always get a rhombus. Okay. Our next case is I am considering a rhombus. Now I am joining the midpoints of the sides of a rhombus. Now I am drawing a diagonal AC and I am also drawing a diagonal BD. In the rhombus, the diagonals are always perpendicular bisectors, isn't it? These are perpendicular bisectors. If you consider ADC triangle and this AC is the third side of this triangle and this RS line segment is exactly parallel to AC and half of it is AC by 2 and this is also AC by 2. Yes, and this is BD by 2 and this is also BD by 2 and here we can also identify the angle. See, as this is perpendicular to this and this is also perpendicular to this, isn't it? So here the angles are 90 degrees. Yes, all angles are equal and each measures 90 degrees and the pair of opposite sides are parallel and equal. Yes, if one of the interior angle is 90 degrees, we can say that this PQRS is a rectangle. We don't know whether AC is equal to BD because in the rhombus we can't say that diagonals are equal in length. They may or may not be equal. That is why we don't know whether AC is equal to BD. So we can say simply this PQRS is a rectangle. If you join the midpoints of the sides of a rhombus, you will always get a rectangle. Next case is a square. I am considering a square. See, I am joining the midpoints of the sides of a square. This is a PQRS quadrilateral. See, if you join AC diagonal and also BD diagonal, we know that in the square, the diagonals are perpendicular bisectors as well as they are equal. AC is equal to BD. Yes, so we know this is AC by 2, this is also AC by 2, this is BD by 2, but we know AC is equal to BD, that is why this is also equal to AC by 2, this is also equal to AC by 2 and as these two diagonals are perpendicular to each other and here also the angle will be perpendicular, isn't it? So one of the interior angle is 90 degrees and the pair of opposite sides are parallel and the adjacent sides are equal. So this is possible only in case of a square. So if you join the midpoints of the sides of a square, you will always get a square. Okay. Now we will summarize what we have discussed just now. Okay. So here a quadrilateral, the type of quadrilateral we are considered and here the figure formed by joining the midpoints of the sides. Okay. So if you consider a quadrilateral, any type of quadrilateral. For quadrilateral and trapezium and parallelogram. For these three types of quadrilaterals, we will always get a figure parallelogram. And if you take isosceles trapezium and rectangle, so for these two, we have got a rhombus. And for a square, again we got a square. And for rhombus as well as kite, for these two, we will always get a rectangle. And these are the figures formed by joining the midpoints of the sides of that type of quadrilateral. So for quadrilateral, trapezium, parallelogram, if we join the midpoints of the sides, then we will always get a parallelogram. If you join the midpoints of the sides of isosceles trapezium as well as rectangle, we will always get a rhombus. And if you join the midpoints of a square, midpoints of the sides of a square, we will always get a square itself. And if you join the midpoints of the sides of a rhombus as well as kite, we will always get a rectangle. So these are the different types of the figures formed by joining the midpoints of the sides. Okay. Thank you.